Solving a system with elimination. There are three ways to solve a system. The first way is by graphing. So you graph where two lines intersect, and they intersect at some point, and that point is the solution they share in common. That would be the solution to the system. The problem with graphing is it's very imprecise if you're doing it by hand. And if your ordered pair was at, say, 3001 negative 2057, it would take a pretty big piece of graph paper for that to work. It's just not practical. But still, keep in mind that every single time when you find the solution to a system, it's where two lines intersect. It's a solution that both equations have in common. The second technique we've already done, it was called substitution. That's where you get the variable by itself and you plug it into the other equation, you substitute into the other equation, and then you solve. And once you solve for one of the variables, you plug that value back in and find the other. The answer is still an ordered pair. It's where two lines intersect. The third technique, which is what we're going to talk about today, is called elimination. Sometimes you'll hear textbooks call this addition or addition subtraction. The idea is you get the equations in standard form where the variables are on one side and the constants are on the other. You line up your x's and your y's. Then you manipulate one of the equations in such a way that a pair of the variables are the same. They're the same number, like 3x and 3x, or negative 2y and 2y. And you either add or subtract and make one of the pairs of variables drop out. I'll show you what that looks like. Before we do that, keep in mind there are three things that can happen. Always, our answer is an ordered pair where two lines intersect. These are the three cases then. You could graph your lines and they intersect at one point. You get one solution. You graph your lines and they end up parallel and you get no solutions. Or it's possible that you graph your line and the two lines end up being right on top of each other, and there are infinite solutions that work in both equations. So one solution, no solutions, or infinite solutions are your possibilities. Here's our first example. So the idea is that we want to make a pair of opposites. Now, I usually go with the opposites because I think you're less likely to make a sign error if you make them opposites. I'll explain. So I could make these two the opposite of each other, and what you want is the least common multiple. Well, notice that 3 times 4 is 12, and 3 divides into 12, 4 divides into 12, so I could make these both 12. To do that, I would take the top equation and multiply it by 4, because 4 times 3 would be 12. And then I take the bottom equation and multiply it by 3, because 3 times 4 makes 12. Now I said I want opposites, so instead of 3, I'd probably use negative 3. However, with this equation, there's an easier way to solve it. Let's take a look. The reason there's an easier way is you don't have to use the x's, you can use the y's. And notice that this y is 20, and that I can make this one 20 if I multiply this equation by 5. And not only that, they'll be opposites. That's what I really like to have as opposites here. So I'll do that. 5 times 3 is 15. Notice I multiply everything by 5. 5 times 4 is negative 20. And 5 times negative 2 is negative 10. And the bottom equation becomes 4x plus 20y equals negative 28. Now I call this elimination because what we're going to do is eliminate a pair of the variables by adding. When you make opposites, you'll always add. Now you could actually subtract every number and make them disappear that way too, but then you'd want to make them the same sign. I prefer to make them opposites because you're less likely to make a sign error when you add. So we'll add everywhere. 15 and 4 make 19x. Negative 20y and positive 20y, see why I made them opposites? They add to 0, equals negative 10, and negative 28 is negative 38. Now get the x by itself, divide by 19, and x will equal negative 2. Now our answer is an ordered pair. We only have one part of the ordered pair. So what I'm going to do is take that negative 2 and plug it in one of the equations. I'm going to use the original equation up top because it looks like it has the smallest numbers. It doesn't matter, either equation will work. 3 times x is negative 2 minus 4y equals negative 2. That's negative 6 minus 4y equals negative 2. Add 6 to both sides. Negative 4y equals 4. Divide by negative 4. And you see that y would be negative 1. So the solution to this equation is negative 2, negative 1. Our solution is an ordered pair, alphabetical order. Make sure you use parentheses for an ordered pair. Put a comma between your numbers. Question 2, another example. Now I want to make a pair of opposites. I could do the x's, in which case this one's 12. I would make the top one negative 12. I'd multiply by negative 3. Or this one's 6. I'd make the top one here negative 6. I'm making a pair of opposites. And what do I multiply 2 by to make it negative 6? How about negative 3? Either one works. I'm going to stick with this one. So the top equation becomes negative 12x minus 6y equals, and negative 3 times 0 is still 0. The bottom equation I just write down underneath it. I have my pair of opposites now, so these are going to add to 0, so I'm going to add up. That's why this is, again, sometimes called addition. Look at that. That's 0. I get 0 equals 0. Now this is a true statement. What that means is that these two equations are the same line. There are infinite solutions. Infinite solutions. So type lowercase o twice to get infinite solutions. Now, if you're not seeing it, observe that if I take 4x plus 2y equals 0, and I solve for y, I get 2y equals negative 4x, and I divide by 2, and I get y is negative 2x. And then if I take the second equation and solve for y, 12x plus 6y equals 0, 6y equals negative 12x, and divide by 6. Notice it's the same equation, y equals negative 2x. When I graph these overlap at every point. That is why there's infinite solutions. They end up being the same line. On question 3, I'm going to have to manipulate both equations. So 2 and 3, the common multiple is 6. They both divide evenly into 6. 6 and 9, well, you might jump to 54, but there's a smaller one. They both divide evenly into 18. So let's go ahead and do the 2 and the 3. I'm going to make the top one 6. I'm going to multiply the 2 by 3. The bottom one I want to be the opposite, so I'll take the 3 by negative 2 to make it negative 6. Multiply both equations. 6x minus 18y equals 66. And negative 6x plus 18y, there's my opposites, equals negative 60. Now I can add them up. And I get 0 on this side. Those drop out and those drop out. Equals 6. Uh-oh, what is going on here? Well, this appears to me to be a no solution. If you're wondering why that is, on why I'm apt to go does not exist, the reason is that these two lines, when you graph them, have the same slope, but they don't intersect. So if we take these equations and solve for y, Negative 6y equals negative 2x plus 22. And divide by, so I subtracted 2x from both sides, minus 2x, minus 2x. And now I'll divide by negative 6. And I get y equals 1/3 x minus 22 over 6 reduces to 11 over 3. If I take the bottom equation and solve for y, I'll subtract 3x from both sides. I get negative 9y equals negative 3x plus 30, and divide by negative 9, and I get y equals 1/3 x minus, see those both divide by 3, 10/3. Now notice how they have the same slope, they're parallel, but they have different intercepts. So we got this situation where they don't ever intersect. That's why there's no solution. This one is written a little differently. Don't pay any attention to the set bracket. That doesn't matter. But they're not in standard form. That's a problem. We need to fix it. The top equation is negative 3x plus 6y equals negative 48. The bottom one is not. So I'm going to line everything up, get the x's together there. So that'll be positive 5x, but I need to move the 6y over. So I have to subtract 6y from each side. So we get 5x minus 6y equals 52. Now this is nice because look, you already got a pair of opposites. So I can just add them up and I get 2x equals, and negative 48 plus 52 is positive 4. Now I'll divide by 2 and I get x equals 2. Now I'm going to plug that back in one of the equations. Take your pick, it doesn't matter. I'll use that one. 5 times 2 minus 6y equals 52. That's 10 minus 6y equals 52. Subtract 10 from both sides. Negative 6y equals 42. Divide by negative 6. And y will equal negative 7. So ordered pair is 2, negative 7. Question 15 has some fractions in it. You don't have to put up with those. Let's just get rid of them. So I need to multiply that equation by something that eliminates a fifth. Well, how about we multiply everything by 5? We'll take 5 times 1x, 5 times 6/5, and 5 times 14/5. So that equation will become negative 5x, the 5's cancel, plus 6y equals the 5's cancel, 14. Now I'll write the other one below. Now you might wonder, does it matter which one's on top? Now think about that before you answer that to yourself. When you add things, does it matter what order you add them in? The answer is no. If I say 3 plus 5 or 5 plus 3, it's the same thing. It's 8. So it doesn't matter which one's on top and which one's below. That's your option. This one's kind of nice because all I need to do is to make a pair of opposites is multiply one of the equations by negative 1. I've got negative 5x and negative 5x. You can take either one. I'll take the bottom one and multiply by negative 1. Now I'm going to rewrite my top one. Negative 5x plus 6y equals 14. And the bottom one becomes 5x minus 5y equals 25. All right, we will add, and we get y equals 39. Take that and plug it back in one of the equations, any one you want. I'm going to use that one. negative 5x plus 6y equals, I need to plug something in for y, don't I? 39, 6 times 39 equals 14. So I'm going to have to get out my calculator. Negative 5x plus, and 6 times 39 is 234 equals 14. Now I'll subtract 234 from both sides. 14 minus 234 is negative 220. Negative 5x equals negative 220. Divide by negative 5. Negative 220 divided by negative 5 is 44. So x is 44. So my ordered pair is 44 for x and 39 for y. Note the instructions on this one. Solve the system by the addition method. So that just means elimination. Again, we're going to make a pair of opposites and add the two equations. This one has decimals. First thing I would do is eliminate the decimals. To eliminate them, multiply by a power of 10. You need to eliminate the decimals, which in this case is 100. I need to move the decimal 2 places. So I'm going to multiply by 100. And this becomes 2x plus 6y equals negative 32. That's much better. Now my other equation, negative 5x minus 4y equals 14. I need a pair of opposites, and the 6 and the 4 both divide into 12. That would work. Or the 2 and the 5 both divide into 10. I'm going to use 10. So I'll multiply the top one by 5, because 5 times 2 is 10. And the bottom one just by positive 2, because 2 times negative 5 will make negative 10. So I'll rewrite those equations. The top one I multiply by 5. I get 10x plus 30y equals negative 160. The bottom equation is negative 10x minus 8y equals 28. And we'll add those up and we get 22y equals negative 132. Now divide by 22 and y will equal negative 6. Now I'm going to plug that back in one of my equations. I'm going to use that one. So negative 5x minus 4 times negative 6 equals 14. Negative 5x, this would be plus 24 equals 14. Subtract 24 from both sides. And negative 5x will equal negative 10. Divide by negative 5. And x equals positive 2. The solution to this system of equations is 2, negative 6. I put this one on the assignment for a couple of reasons. First of all, I want you to know how to get rid of fractions, so we'll do that. Secondly, sometimes rather than x comma y, you'll see other variables. So this is common. And what you need to realize is that just like when you say x comma y, your variables always go in alphabetical order. So if it's a and b, it'll be a comma b, just like x comma y. Or if it's m and n, it'll be m comma n, always alphabetically. That's why they've written a comma b. Let's get rid of fractions. The top equation, I'm going to multiply everything by 4, and I get negative a minus b equals 4. Notice I multiplied each thing by 4. The bottom equation, we need a common multiple of 3 and 6. It's the smallest number they both divide into evenly. And the smallest number 6 divides into is 6. Don't take greatest common factor. It's least common multiple. So the least common multiple is 6. I'll take 6 times a over 3. Well, 6 divided by 3 is 2. So that'll be 2a. 6 times b over 6. The 6's cancel, and that'll be plus b. And 6 times 1 is 6. Now this turned out to be nice. I already have a pair of opposites, so I can line things up and add. And negative a and 2a make a. The b's drop out, becomes 0. 4 and 6 makes 10. Now I'm going to take and plug that back in one of the equations. How about this one? 2 times 10 plus b equals 6. 20 plus b equals 6. Subtract 20 from both sides, and b will equal negative 14. So that's it. In alphabetical order then, our ordered pair is 10, comma, negative 14.